Today we shall see Science 1, Chapter 3, Current Electricity, Part 2. In the first part, we had seen what are free electrons. What are free electrons? That is, one or more outermost electrons which are very weakly bound to the nucleus. These are called as free electrons. And the motion of the electrons are random in the wire, and once a potential difference is applied to the wire, then the direction of flow of electron is from lower potential to higher potential, or from negative to positive. And the direction of conventional current will be from higher potential to lower potential, that is from positive to negative. Now, in this part, we shall see what is electric current. What is electric current? It is nothing but the flow of electrons through a conductor, as you can see in the picture. Quantitatively, then, the electric current can be defined, that is, electric current is denoted by capital I. It can be defined as the charge passing through a conductor in unit time. If charge Q is flowing through a cross section of a conductor in time t, then the current I will be equal to Q upon T. The unit of charge in SI unit is Coulomb. Current is expressed in ampere. The current is expressed in ampere after the French mathematician and scientist Ampere, who conducted number of experiments on electricity. Today, we can measure the current flowing in a conductor only because of his extraordinary work. The unit of current is called ampere in recognition of his great work. So, what is 1 ampere? 1 ampere current is said to flow in a conductor if 1 coulomb charge flows through it every second. 1 ampere is equal to 1 coulomb upon 1 second. The charge of 1 electron is 1.6 multiplied by 10 raised to minus 19 C. Hence, you have understood what is electric current. Very small values of current are expressed in following units. 1 milliampere is equal to 10 raised to minus 3 A. 1 microampere is equal to 10 raised to minus 6 A. Now we shall see resistance and what is Ohm's law. What is Ohm's law? The first and perhaps most important relationship between current, voltage and resistance is called Ohm's law, discovered by George Simon Ohm. Now we shall understand each concept, that is what is current, voltage and resistance. Now we already know what is current, which we have studied in first part. Now still we'll revise again. Now what is current? An electric circuit which is formed when a conductor path is created to allow electric charge to continuously move, which we refer in simple terms as flow of liquid through a hollow pipe. Now that flow of current from one end of the other end, or you can say from higher potential to lower potential, from positive end to negative end, is called as electric current. Now next we shall see what is voltage. Now the force motivating or pushing the charge to flow in a circuit is called as voltage. So what is voltage? It is nothing but the force that is applied to the current to flow from one end of the conductor to another end. So voltage is actually a potential difference between 2 points. When we speak of a certain amount of voltage being present in a circuit, we are actually referring to the measurement of how much potential difference exists to move the charge from one point in a circuit to another point. Now that is what is the meaning of voltage. Now what is resistance? Current always tends to move through the conductor with some degree of friction or opposition to motion, and this opposition to motion is called resistance. Now we have understood all the three concepts, what is the meaning of current, voltage and resistance. Now we shall see the relationship between each of them. The amount of current in a circuit depends on the amount of voltage and the amount of resistance in the circuit to oppose the current flow. And each unit of measurement is named after the famous experimenter in electricity. The amp after Frenchman Andre M. Ampere, volt named after Italian Alessandro Volta, and ohm named after the German George Simon Ohm. Now, in simple way, Ohm's law states that electric current is directly proportional to voltage and inversely proportional to resistance. It means that increasing the voltage will increase the current while increasing the resistance will cause the current to decrease. That means if we increase the volt, the current flow will also increase. If we decrease the volt, then the flow of current will also decrease. If we increase the resistance, then the flow of current will decrease, and if we decrease the resistance, the flow of current will increase. So we have understood what is Ohm's law. We can obtain the SI unit of resistance from the above formula. Now, potential difference and current are measured in volts and amperes. The unit of resistance is called as ohm. So 1 ohm is 1 volt upon divided or upon 1 ampere. That means if 1 ampere current flows through the conductor when 1 volt potential difference is applied between its ends, then the resistance of the conductor is 1 ohm. Now children, there is a simple trick to remember, or it is a simple trick how to solve any one quantity if the other two quantities are given. You can see in the diagram or in the picture a triangle wherein the letters are written, that is V, I and R. Now if you arrange the letter as it is, as you can see in the picture. Now for example, if you know voltage and I, that is V and I, and you want to determine the value of R, then just remove or eliminate R and you see what is left. What is left? You see that V and I is left, that is V upon I. Similar way, if you know the value of V and R and you wish to determine the value of I, you just eliminate I and see what's left. That you see that V and R is left, that is V upon R. Similar way, if you know the value of IR and R and you wish to determine the value of V, eliminate V and what's left, that is product of I and R. So in this way, you can easily remember the formula. As you can see in the layout of the circuit, that when the voltage is increases, the current flow is also increases. When the voltage is decreases, the flow of current also decreases. But when the resistance is increases, then the flow of current decreases. That means the current is directly proportional to voltage but inversely proportional to resistance. Now we shall see resistance and resistivity of a conductor. Now we know that there are large number of free electrons in a conductor and they are always in a random motion. When a potential difference is applied between the two ends of the conductor, then these electrons starts moving from the end at a lower potential to the other end at a higher potential, and this directional motion of electron causes the flow of current. Now moving electrons strike the atoms and ions which lie along the path, and such collision cause hindrance to the flow of electrons and they oppose the current, and this hindrance is called the resistance, as you can see in the picture. Now what is resistivity? At a given temperature, the resistance of a conductor depends on its length, area of cross section, and the material it is made of. So, suppose if the resistance of a conductor is R, then R is directly proportional to the length and inversely proportional to the cross section area. So we get that, then we get the formula as R is equal to rho L upon A. Now rho is the constant of proportionality and is called the resistivity of the material. The SI unit is ohm meter. So what is the difference between resistance and resistivity of the material? So resistance and resistivity of the material is that resistance always opposes the flow of electrons, whereas resistivity is the property of the material which defines the resistance of the material having specific dimension. Now the next you can see what is electric circuit. It is nothing but a continuous path of an electric current through conducting wires connected to the two ends of a cell and other resistance, and this is called as electric circuit. As you can see in the picture, the figure you can see how different components are to be connected in the circuit by using special symbols for each of the components, and such a figure is called an electric circuit diagram. Now you can see that an ammeter is used to measure current, a voltmeter to measure the potential difference between the two ends of a resistor, as the voltmeter has a very high resistance, only very small current flows through it.